Well, welcome everybody. Again, my name is James Stanger, and I'm very pleased to be here. Come from CompTIA. How many of you are CompTIA certified? All right, fantastic. Why don't you shout out real quick what certifications you have? I'm curious. Network Plus, what else? Was that A Plus? Any Security Plus folks? All right, those are the big three. I see them. I'm A Plus, Network Plus, Security Plus, all sorts of pluses certified. Okay, so yes, I am certifiable. CompTIA, if you don't know who we are, it's not CompTIA, it's not CompTIA, it's CompTIA. We do an enormous amount of things. We're driven by the industry, so value-added resellers, companies as large as Lenovo, Apple, Dell are members and work with us. We do what the industry tells us to do. We also do a lot of philanthropy. We just recently merged with the Association of IT Professionals. So we do an enormous amount of things, including certification. My job is to lead the certification efforts. I'm over all of the certifications. So if you have A+, Network Plus, Security Plus, you like those, CSA Plus, our new cert. If you like those, come and thank me, right? If you don't like them, Steven Schneider, also from CompTIA, you can go talk to him. All right, just kidding. Over the year, I'm also over the CE program, and so I'm glad that the CE program was mentioned. So anybody who needs CEUs, you can make sure you get scanned. So I'm happy to be here. Not only have I done a lot of work in certification, I've done a lot of work in the open source community. I think I cracked open my first Linux box in, I'm trying to remember here, about 95? Not 92. I don't know Linus Torvalds, but I do know where he goes diving. He lives in Portland, Oregon, and he goes diving in the Puget Sound and the Hood Canal, where I go. I've done a lot of work in that area, and that's started my journey into security. Over the years, I've done a lot of work with security auditing, penetration testing, also security analytics. Also have a lot of web design. So there's some of my skills. Moving on to the good stuff. Let's talk a bit about some killer and key events and a few conundrums, couple issues here, and how visualization and practical analytics can help bring about a little bit of improvement to our security situation. We're going to talk about technology changes that have affected our security practices, some answers, and some skills and tricks for visualizing trends on the network. I noticed, had you guys say raise your hands or shout things out. Notice there's a microphone right here. If anybody has any questions at all, feel free to stop me at any time. And you can come up to the microphone and ask a question. I want to make this session as interactive as possible. So let's go ahead and move forward. You know, over the years, we conduct various surveys. One of the surveys that we conducted was effectively around the idea of how do you monitor and visualize security issues and trends over time? Because we find that that is a very important thing to be doing. Now, none of this stuff that I'm going to be showing you today is a magic silver bullet. There is none in regards to security. If it was, we would all have pulled that trigger and fired that bullet, etc., and solved the problem. But I do believe there are ways that we can move the needle. I do believe that there are ways that we can solve some issues. So we basically went and asked a lot of these companies, well, all of these companies here. Target, for example. I know a guy named Tim Carruthers who got hired just after the 2014 Thanksgiving hack. You guys know what I'm talking about? Thanksgiving time frame. Who here had to get their credit cards replaced? Yeah. I got a long story about that. Come to me afterwards. I got a pretty good one. Tim was hired after that to solve that problem. We also talked with people at Western Digital, Oracle, Costco, and we asked them questions about what are some of the ways in which you visualize trends on the network and some of the issues there. And, well, they answered back with kind of a long story. It's a good long story, and it's a story about events, some challenges, and some observations and kind of a conundrum. First of all, we got an answer here about the concept of the attack surface. Anybody ever heard that term before? Attack surface. It's the surface that a company or an individual or a device even presents to the attacker, right? Let's talk about as a company, right? How many openings in the company are there that invite some form of attack? Well, all of this boils down to this slide, and I'm going to spend a bit of time on it. And by the way, for those of you, some people taking pictures, great, thank you, very flattering. I'm sure it's not of me, it's of the slides. I'll make the slides available to you. I'll get a link to you. If you come up and give me your card, don't worry, I won't sell it to anybody. Well, maybe I will. No, I won't. Give me your card or whatever, and I can send it to you, or you can send me an email, okay? And and in fact, I'll even have it up on my Twitter account, and you can go and grab the link there, okay? So the first issue has to do with the evolving endpoint. I think some of us are old enough to remember what it was like to deal with the mainframes of old, right? We dealt with the dumb terminals, and all of us know the distributed computing scene, PCs. We all remember when 10 years ago the smartphone came in. These are evolutions of the endpoint. I do find it interesting that with the advent of the cloud, the phone is now the dumb terminal, or much smarter terminal, and the cloud is basically the mainframe. I've always said we've come to mainframe 2.0 now, which is fine. But the evolving endpoint, one of the major shifts has been IoT. IoT is not coming, it's here. It's here. It's been with us for a lot longer than we realize. And with the Internet of Things, that has been one of the major changes. The endpoint has morphed from some sort of PC or handheld device to your car, to your glasses. I can't wait till I IP enable these things, because then I can know where around the world I've left them. Second, the perimeter has dissolved. What does that mean? Couple of things. First of all, with endpoints inside and outside the network, you basically have, with BYOD, devices are all over the place. Second of all, the cloud. The cloud is here. In other words, up to 10 years ago, the firewall demarked the difference between the inside and the outside. It was a physical demarcation, right? You could actually point to it and go, there you go. Now, you tell me where the perimeter is. Yes, we still use firewalls. I get it. We use switches and we use routers and we put them all together and segment networks. I get it. But more and more, that concept of the perimeter has really dissolved in large part. Third, encrypted traffic. Back in the day, encrypted traffic wasn't encrypted. Then we started encrypting certain things that were sensitive. Now we encrypt everything. Guess what? So do the hackers. So how do we visualize network that's encrypted? How do we get into it and understand it better? That's a challenge. It's easier than ever before to get a Tor network going, or whatever hip replacement there is for Tor, right? Another one, a lot of different security controls. We have a lot of compliance going on. You have the people over at CI Security. They have 20 controls. You have the OWASP controls. Do you guys know what I'm talking about, the OWASP controls? How many of those are there? Yeah, about that many. We've been using them more and more. The other thing that's been happening, too, is over the years, there's been a lot of hardware controls introduced. Firewalls, routers, switches, etc., right? Endpoint devices, silent devices. Also software controls and encryption. So many, in fact, it's tough to keep track of them. Incident response has morphed and become much more sophisticated. Privacy is a major issue now. Why is that? Fairly simple answer. Entities that, until now, just kind of considered themselves, hey, look, we make hard disks. Western Digital, Seagate, right? Or entities that provide power, right? Power companies. Look, that's all we do. But guess what they can do now? I've spent time talking with the person who leads the Skunk Works over at Western Digital. Well, Western Digital realizes, hey, we can gather data too. Google says they own, the search. Great, right? The Verizons, the Comcasts of the world, they own the pipe. Okay, great, right? Western Digital owns almost 2 out of every 3 hard disks on your systems. So the smartphone that's in your pocket, chances are it's a Western Digital device. They own that space. So you have the power companies. They're now saying, we can start collecting data and do Google Analytics and sell that and turn it from data into information. So privacy has become a major issue. And one of the concepts that's really important to understand is you can impose all sorts of security measures, authentication, the CIA triad if you're a CISSP, all of those things. But you can't impose privacy unless you first have your security ducks in a row. So to put it in an almost Latin kind of epigram, you can have security without privacy, but you can never have privacy unless you have security first. So these are the major issues. All of them actually have increased the attack surface. Privacy has increased the attack surface simply this, because now we are all collecting data and turning it into information. That makes your company, your organization, your division, whatever, much more susceptible to, if not susceptible to attack, much more attractive to an attack. Moving on. Each of the entities we talked to all used a phrase very similar, a rolling series of wake-up calls and attacks that started really from about 2014. I shouldn't say they started. We've had attacks for many, many years. But in 2014, things seemed to get pretty serious. Increase of ransomware, business email client compromises, attacks, advanced persistent threats. And we basically, I basically put up on here, like in the UK, you have 6 million customers. Their personally identifiable information was stolen. Information that made it possible for anybody to do identity theft. Dyn. Remember last October? I'll show you a heat map of that shortly. Remember that attack that brought down a lot of things? It brought down Microsoft. More importantly, it brought down Netflix. I'm not sure I survived the night. I couldn't binge watch my Star Trek. That got personal. We all know about the attack on the government. Human services attack, 21.5 million people, etc. In some ways, it started a lot with that Target attack. And so these are major issues. And it woke us, everybody, the mainstream, even though people knew about the advanced persistent threat, it really woke people up to what the advanced persistent threat is. My favorite analogy, who's here has heard of the APT? I won't go into it too much, right? My favorite analogy is the difference between a smash and grab, somebody smashes a rock into a window and grabs something, and somebody who very stealthily enters into your store and lurks around and keeps lurking around after hours, and keeps lurking around and keeps learning more about your business, and then they spread to other businesses. Okay. It used to be that it was state sponsors that did that. There are a lot of people, a lot of companies involved in espionage. There are a lot of individuals that frankly have access to sophisticated resources. They can do advanced persistent threats more than just North Korea or whomever, okay? So that's one of the major issues. The security issues involve weak authentication at endpoints. It involves the lack of practical monitoring. And of course, the main reason why people go after all this is IP theft. And they're also looking to compromise additional organizations. Once they've gone from one system to the next, one organization, then they attack the other. So your organization simply might be a stepping stone to the next one. So this is a major issue, the advanced persistent threat that we talked about. This here is a really lame screenshot. The reason why it is because I was able to get a hold somebody, actually it was a help desk person, said, hey, check it out, somebody got hit by ransomware. And I took my phone and took a picture of it. That's why it looks so goofy. All right? That's WannaCry. All right? It's one of the biggest issues that's facing us today. I was talking to a guy named John Dvorak. I'm not talking about the columnist. I'm talking about a former FBI agent who I think he conservatively put it at $1 billion a business that's now gone to the cloud. Hacking as a service. I'll talk about that in a second. But there's a big question, how to address and handle ransomware. What can security analytics or visualization do to help solve this problem? Other issues, the business email compromise, which is very, very closely related. In other words, this type of ransomware tends to get downloaded by individuals who get tricked through their email. I was talking last week in London to a security analyst. I said, what do you do? Day in and day out, what's the consistent activity? She says, I track end users. That's what I do, because we're trying to stop malware and illicit servers and various forms of malware to get installed, right? And I asked her, what's your killer tool? What's the tool that you use every day? She said, well, if you're talking about software, she said, frankly, it's spreadsheets, statistics that show me how many end users are clicking on bad links. She said, but my killer tool is actually analytics, my brain, right? And I said, well, how do you visualize that for your boss? And she gave me a couple of clues, and that's why I'm talking to you today. I'll talk about that in a minute. But there's the business email compromise. Then there's the idea of the business process compromise. They're really very similar. One just focuses on the end user, one focuses on the executive. The other thing that companies are very worried about and continue to be worried about is what I think is an old problem that's become new. What year did you first hear about a denial of service attack or a distributed one? Can you shout it out really loud? What year did you first hear about one? Can't hear you. 95, 98? Absolutely. I heard about those back when I was getting my degree in unemployment English. I heard about those back then, and they got pretty serious around 2000, didn't they? 99, 98. Remember Melissa and I Love You and all that old stuff, right? And I remember talking to people and saying, well, actually, the problem's going to get worse eventually. I said, well, why? And when I said people, I'm talking to security hotshots back then. And they said, homogeneous devices are going to cause the problem. And I'm like, homogeneous, huh? They said, devices that are similar to each other. Because anytime you have a bunch of similar devices, it's like walking into a naive population with smallpox, and none of us has smallpox inoculations anymore. Even you old-timers like me, we got them back when we were kids, but they probably are no longer effective. If somebody were to walk in right now with smallpox, we'd all get it, okay? My point is that's an analogy that anytime you have a lot of systems, like IoT devices, that are very similar, that are manufactured by probably about 4 different major manufacturers that are using firmware that has been created quickly, speed to market over security, you got yourself another environment that makes the old Windows 95 devices, the old Windows 2000 issues look tame. Okay, another issue, let's see if I went too forward here. What am I doing here? Yeah, okay. I seem to have skipped here. Hold on, I'm losing my mind. Okay, what are we doing here? Somehow I've gotten lost. I feel better now. So, next, hacking as a service. It used to be, folks, that if you wanted to go attack somebody, you would go and take some sort of class, and then you'd learn how to attack something, and then, right? Why would you ever have to do that now? Just hire it done. That's what's happening. Here's a screenshot taken from the dark web. I grabbed this, right, of somebody putting up services. Now, I'm not saying this person, whoever it is, whoever that person is, can really do all of this. But this person is basically saying, for about €7, I can basically start your own market, or I can get a botnet going for about €426. $600, right? That's as a service. So you don't have to do it. You just hire it done. That's a major issue. The Internet of Things is fun. I've already talked a bit about this. The idea that with all of it's a $1.9 trillion business, it's getting bigger than that. You have a lot of devices. I don't even know how to say that 24 with all the zeros, and I don't even care. What I do care, though, is what the issue is. Now, the promise of IoT, right, is here. See that heat map there? That's a heat map. You guys got an idea what that's all about, what that's for? Basically, imagine if I had an IoT device, right, my IP-enabled glasses, and then I start walking into a store. Look, what are those red bits all about? Yeah, that's where I stayed the most, right? Or that's where the most people stayed the most, right? So the idea is that a good marketer, or even a bad one, can go, well, I know where people are spending their time. I can do targeted marketing. I can rearrange the store, okay? That's the promise of IoT. Right? Now, from a techie perspective, right, we set it up, we maintain it, right, we govern it, we do data analytics, all of that. That's the promise of IoT. Here's what IoT, if I can get this thing to work, became last October. That's the Dodin attack that happened. You guys know what I'm talking about? It was a botnet-driven attack on IoT devices. A lot of devices, baby monitors were involved in this, okay? And they attacked the seaboards. They attacked areas in the middle. You know what those areas in the middle were? A lot of backbones, right? They were going down southwest, right down the middle, up in Minnesota and across. A lot of the telco lines. And, of course, the seaboards. They went after the Bay Area and L.A. They went after East Coast. When I go abroad, sometimes when I travel, I show another heat map. It's the same sort of thing, but it just shows how it went after Japan and Great Britain as well. This here is something that happened just last month. This is somebody's rendition of WannaCry. Check out how Japan got hit pretty hard. Look at the West Coast, East Coast, Europe. That's just one person's idea of the issues. Those are the issues here. So how do we visualize our response to these things? Well, before I get into that, it's kind of a conundrum, right? More resources have been directed than ever before at these kinds of attacks, and yet the attacks seem to be on the increase. As a business person, I'm no great business person, but as a business person, you're going to sit back and go, wait a minute, I've been spending more on teaching people, I've been spending a lot more on software, I've been spending a lot on hardware, and yet the problem seems to be getting worse. We're going the wrong direction. That's the conundrum. Usually, if you're smart and spend more money on something, you end up solving the problem a bit, but we seem to be going the other way. So what other approaches can help reverse this trend? Well, one is an understanding of the kill chain. How many of you have heard of the concept of the kill chain? Okay, most of you have. I won't belabor it. 7 steps. There's a link to it if you want to learn more about it. It's based on the F2T2EA idea, right? Find, fix, track, target, engage, and assess. The question becomes, if you're going to invoke something like the kill chain and understanding how to stop a threat, how can you best map each of the activities of an attacker, whether it be an advanced persistent threat, whether it be a business email compromise? How can you best take each of those steps and map it to an activity or to something that is verifiable and analyzable? And then you can go in and say, okay, look, here's where we are along the lines of the kill chain. Here's where the attacker got in, how the attacker is spreading from system to system, etc. So again, Lockheed Martin kind of got this idea from a very military idea, right? F2T2EA, which is a fairly new concept to me. How many of you have heard of that concept before? Okay, we're in the military, so okay. So the Lockheed Martin employees took that, created the concept of the kill chain. I'll move on. Many companies have taken this concept or some concept of framework and have applied it to the advanced persistent threat and to the kill chain. So check out here what we've got here. This here was given to me by a guy named Tim Carruthers who works for Target. This is not my idea. This is something that came directly from industry. And this is where he said, James, what we have to do is we have to start visualizing and start looking at the results or the activities involved in each of the steps. See here, there's the initial compromise. Here's where you're establishing the foothold. I'm not saying that this is the exact same kill chain steps, but they're very close. They're very related. And basically what he's saying is you need to go in here and if there's an initial compromise, what does that initial compromise look like of a system? What does that foothold look like? What are the activities? And you start filling in this matrix. And then you start putting in how you solve the problem, how you mitigate it. So it's not just, I've taken many courses that start here and end here. And I've taken some courses that have, and talked to some people who start talking about how you inhibit and go in and how you identify the traces left behind by these attacks. A lot of times this mitigation is never really covered. So how do you visualize this? Well, here's the beginning of an example. Tony Stanger wrote the black stuff. Tony Stanger is formerly of the NSA, works for a company called CI Security right now. Terrific guy. He basically put together the idea, well, here's the attack stage, right? So you have reconnaissance. What does reconnaissance mean? Shout it out. Scanning. Did you say scanning? Thank you. Then you have delivery of the system, right, and on through to installation. How can you say, when it comes to the help desk, start mapping these activities and start identifying these activities? That's the beginning of creating a matrix that allows you to start visualizing how attacks are happening on your network. Why is this important? Because we all have bosses. And frankly, our bosses are not interested in too much detail, are they? One of the main problems of the Target attack back in the day, it was 2 problems. One, they installed software based on compliance, and then they left the defaults going. Okay? They didn't customize anything. That's the first problem. Second problem that resulted from that is they just started getting a whole lot of info. Even worse than me talking to you today. Just way too much info, right? So what do you do when you get too much info? When your kids start chattering at you, what do? Yeah, you go travel to AFCEA. Yeah, good answer. All right? You just tune it out. And that's what happens. So the question becomes, when you are talking to your boss, how can you, without your hair on fire, go and say, we need to pivot, to use a fancy 2017 word, resources to the right attacks. How do you do that? With lots of words? No. You start with this. You start with, see if I can go backwards. with some form of framework and matrix and start mapping things across so that you can identify and say, and these are the steps where we are, and here are the systems that are under attack, and here's where we need to devote resources. And that might be, if we go after our end users, when I say go after our end users, when we train our end users better, maybe that's it. Or, well, actually, there's a series of endpoints that are really the major problem and all that. That's kind of where we need to be going here. Excuse me while I do a time check. We got a half hour left. Okay. Moving right along. So our job is to map threats to vulnerabilities. After all, that's what an attack is to all you CISSPs, right? You identify trends over time. You focus on key controls, and you determine how well those controls are working. Don't worry, I'll be showing you some cool software here in a minute. But I wanted to lay the foundation of what it means to do the initial mapping here. Stephen over here has done many mappings when it comes to one program to the next, right? CompTIA to other certifications or CompTIA to business requirements. You're now here doing a mapping where you have an indicator of an attack. And these here, along here, are examples that I've taken from the industry of a lot of the major attacks. These things are not just James Stanger coming up with it. These are things that CompTIA has noticed through surveys of a lot of the major types of attacks that seem to be happening, right? And then what the possible issue is. Now, the possible issue of an internal host connecting to an unknown destination, hey, that just might be unproductive surfing on the part of an end user. Okay? But if you visualize it and take a look at it and you see a persistent connection that's encrypted to some sort of from some sort of host, right? An endpoint could even be from a DMZ system if you're really unlucky. That could mean somebody is grabbing all your data and streaming it out to the dark web or to a third party who's going to exploit it. Questions so far? If you have any questions, again, just feel free to stand up here. I'm happy to try to answer any of them that you have. Internal hosts using non-standard or new ports suddenly, right? That comes up, right? An illicit server has been installed. Is that the case always? Not necessarily, but if you don't know why, you need to take a look at it. How can you visualize this? These are the applications of the ways in which you can visualize those things. I've noticed that a lot of people don't take this kind of step. Now, you can fill in each of these issues based on your matrix, right? But a lot of people don't take that initial step. What do? We stampede into installing some sort of fancy piece of visualizing software or something like that and go, hey, cool, isn't that, look, it works. Let's take a step back and plan that installation. And let's take a step back and make sure that we really know how this software will work for our network. Because each of your networks is going to be different and going to behave differently. Moving right along. So here's an example of somebody who's basically said, okay, I'm concerned about network scans from hosts, right? We've been noticing an increase of TCP-based scans, UDP-based BORT scans, right? There's some other additional things, much smaller things. I'm not saying any of these is necessarily good or bad, but it's the idea of how can you visualize network traffic so that you can tell the difference between a system booting up and it's a bunch of DHCP happening and TCP-based scans. Pretty easy way to do that. But how can you tell the difference between between a system doing a normal network discovery, as a lot of peer-based things do, and actual attacks? And it's this visualization that will enable you to talk to your boss properly. So here's an applied example. This here is an example of malware that had been installed on a system. Let's see if I can tell the story right. Talking to a gentleman who basically was responsible for a conveyor belt. It was a conveyor belt working for a system. Downtime was about 4,000 pounds an hour. So every hour that conveyor belt was down, the company's losing 4,000 pounds. About $6,500 bucks. Is that about right? Depending on who is prime minister at the time. What he was worried about is they discovered that the system that was being used to control the conveyor belt, right, was also being used by workers to surf the web. So you have a critical piece of machinery, right, and a critical piece of control, right? And instead of them using it right, they were just browsing the web with it, right? Well, the solution was, stop doing that, right? Well, what was the problem with that? These are union workers. And the security worker couldn't tell the union workers not to do anything. So I don't work for you. I'm a member of the union. You can't tell my union brother to do that, just whatever. How do you solve that problem, right? He went to visualization and he was able to say, look, we are seeing an increase of ransomware attacks based on endpoints, right? Do you really want to get locked out of your conveyor belt so that it always keeps going or it never stops or whatever? And the union was like kind of flummoxed. They're like, yeah, we get it. Okay, you help me see the need there, but I can't tell the union guys to stop surfing on the web, right? So guess what they did? Based on that visualization, based on the fact that it was a lot of money, they basically went, well, it's only about 3 or 4 workers that really have control over this system. How about we get them all brand new iPads that they can have on their own, and we'll even give them to them, right? Because 4,000 pounds an hour is a lot more than 2 or 3 iPads. And then they basically set up a segmented network so that they could go right out to the web and browse their system. And then they just naturally lost interest in surfing on that device, right? And they basically solved a problem. What does that have to do with visualization? Visualization kind of got the creative thinking going. It got the idea going that if you show something as an issue, it's like, ooh, that is a major issue. It's not just a security person going nuts or having their hair on fire or being a security person. They're actually thinking things through and showing it. It actually broke through and they solved a problem. That's where visualization could come in. I just wanted to give a practical example of that. Let's talk about some of the major pressing issues based on a lot of these technologies today here. First of all, where do the attacks occur? And this is a fancy word, interstices. What does that mean? In between. It's where one thing, technology, connects with another, right? And I've given a bunch of examples of where one thing or whatever connects to another. And my favorite is, of course, where meat space. What does meat space mean? People, us, right? Meat space, right? Connect with cyberspace. That's why business email compromise are an issue. That's why ransomware is an issue. But there's much more sophisticated issues as well. Wireless access points. Old wireless access points, they all encrypt, right? They encrypt the incoming traffic. They encrypt the outgoing traffic. But guess what a lot of the older ones do? While they're reading the traffic and making decisions about where to route things, et cetera, and how to do it, it's unencrypted there. So a good hacker can go in, attack that device, and read everything. Trust me, those devices are in your systems. Where one technology meets another, in other words, where wired meets wireless, or where one set of traffic comes in to another, that's a major issue. SMS, how many of you use Facebook? I don't anymore. It's not because it's insecure. It is secure. It's just I just don't care. But who uses Facebook? Anybody want to admit it? Okay? It's a very useful tool. We use it at CompTIA a lot. I just don't. Do you remember when you had the ability to say, hey, I lost my password, and you could use your phone and text to have your password sent to you? Right? What's the problem with that? It uses, yes, web technologies that are encrypted, right? But it also uses the old SMS system, right? That's a system that's been around since the 1980s. Guess what? It doesn't use authentication or encryption at all. Or if it does, it's trivial. My point being that hackers identified that very quickly. They got on the backbones, not that hard to do, and they basically started looking and doing searches for SMB-based traffic, right? For SMS, sorry about that. SMS-based traffic, right? And they were trivially grabbing everybody's password. And if you're like a lot of end users, their Facebook password is their password to other things, maybe even their bank account. You get the idea. SQL injection, all of these ways, in other words, where web technologies and database technologies match. That's where a lot of these attacks happen, right? Moving on, there's this case in point. I was talking to a CISO of a large optics provider. He told me not to give the name of the company, but they sell a whole lot of contacts. And he basically said after a security incident, the board said, hey, we need some improvements. So they spent a whole lot of money, about $30 million on all sorts of improvements. And as the security consultant came in and said, okay, here's what we've done or whatever, the CISO basically went and noticed a lonely little HR server, noticed that it was kind of sitting there and basically conducted a SQL injection attack and downloaded the entire HR database, people's social security numbers, their names, their addresses, phone numbers, right? What happened? The consultant wasn't able to didn't go in and conduct the right amount of discovery, right? How did this happen? How could that be after spending all that money? Well, people like to buy things. We like to buy services, IT people. We like to buy hardware. We like to buy software. What we don't do is we don't visualize the network properly. There's also issues having to do with compliance, right? Compliance is a good thing. I'm not saying it's a bad thing. We have to do it. We have to comply for PCI or HIPAA or FISMA, other compliance. But if you get into the compliance mentality, you give up your thought process sometimes. You stop thinking about what it means to do a visualization and things like that, and you end up just saying, okay, we ticked the checkbox, as the Brits would say, and you move on. This is where you end up with the primary challenge of almost 50% of the people in the security industry that we polled saying, well, we do a lot of combating of people who say that our security is good enough, 47%. Why? Well, because we're FISMA compliant or we're compliant with PCI. That's not necessarily going to stop the hackers. Okay. The other issue has to do with lack of baselines. Yes, we have lots of firewalls, we have default settings, but the real issue is that you have to identify true anomalies. And so there's this issue having to do with, well, how do we go ahead and make a baseline? And this leads to too much information, as I mentioned before. And it's a phrase that I stole from Tony Sager, the fog of more. I think we all have heard the phrase, the fog of war, right? The fog of more simply means there's too much information, right? So let's give some answers, okay, some ways in which we can move on. First of all, you have to move on beyond signature-based attacks and signature-based thinking. In other words, moving beyond antivirus, moving beyond firewall rules, intrusion detection, and start thinking in terms of heuristic solutions. And this is an example here of a SIEM, of a security information event manager. I'm not saying that they're a magic bullet, but they can help us visualize trends much better. Can anybody tell what that washed out thing is? That is me going up Snowdon in Wales. It's a mountain in Wales, England, right? It was a whiteout. We had a lot of fog, a lot of snow. I was able to finally notice the trail, right? Can you kind of tell where the trail is there? But this picture doesn't do justice. If you take one step that far, and if you don't have a what's it called, ice axe, like I did not, you won't stop for about 1,000 feet, right? That means you're going to be in a world of hurt, right? Dead or worse, right? What does that have to do with the fog of war or whatever? I think all of us are a lot of people, if they don't visualize properly, are taking very small steps up the mountain, as it were, trying to solve things, but they are very close to doom. We need to have ways to find actionable information. So behavioral analytics and visualization is critical, and you have to coordinate both factors. By behavioral analytics, I mean people's behavior, individuals' behavior. You can tie it right back to individuals' login, but also how the network behaves. In other words, you look for trends, and then you look for anomalies. I think most of us already understand that concept. But the key is, how do we go about visualizing things so that you can take action and have your bosses take action? So the first thing, as I mentioned, security controls, that there are a lot of them there. The key is basically finding ways to get visualized realizations of how well those controls are working or aren't working. So if you're doing something along the lines of compliance, you say, look, here's what we've complied to. Visualize that. Now take a look at the network traffic and where the issues seem to be going. Has our compliance solved the problem? Man, if you're lucky, fantastic. A lot of times it is. But frankly, what happens is the attackers find out that 1% or that certain percent where your compliance-based approach has not solved the problem, and they attack it. Right? So one of the best ways to inventory that I noticed, according to our survey, is this. We do not only a hardware inventory and monitoring network traffic, but also you focus on layer 7. In other words, I think that when, for example, that individual who spent part of the $30 million, was responsible for that, and then got hacked in front of the board with a SQL injection attack, they didn't take a look at their layer 7 applications. They didn't take a look at, and why is that? Because they weren't visualizing things properly. They were just kind of plugging things in. So I think it's here at layer 7 where it's very important. If you do that, it also cuts down on too much information because you can start taking a very nice inventory of layer 7, layer 1, and everything in between. There we go. Practical baselines that the industry has told us are important. First of all, focusing on authentication and logins, repetitive, out of normal time. That takes care of account aging. Encryption. You need to do a survey, and this is, some people say layer 6, some people say layer 7. You need to do a survey of the types of encryption that are allowed on the network. If you're not doing that, you're not going to be able to properly visualize anything. When it comes to infrastructure, there's routing and traffic. Inside and outside, egress and ingress, right? We get it. I think that's pretty common. I think one of the big things that happens is a lot of times people feel, well, the reason why we're having latency is because there's a router loop going on. A lot of times, routing loops I shouldn't say a lot of times, they can be attacks. And so you have to be able to determine the difference between a router issue and an actual attack. Endpoint, you focus on, the traffic analysis on the patch level. A lot of people don't focus on the firmware like they should. And then, of course, there's network and app segmentation. How can you go about creating various trust zones? So these are basic practical baselines that will help. When it comes to firewalls, they can help as well. One of the things that we've noticed people are doing is they're running clouds through the proxy to the log service, because logging is basically kind of like this. When I was going up Mount Snowdon in the UK, I noticed every once in a while there were these cairns, these people where they put together stones. The reason for that, people get lost. Right? And so what happens is as they go along the way, when the trail gets bad, people pick up a rock and start throwing it there, and it's mileposts along the way. Visualization, once again. One of the things that we've noticed is that most companies are not implementing multi-factor authentication like they should. When I say companies, I mean organizations. Because the problem is at the endpoints, and if you're just relying on that password, you have an issue. So visualize the idea of who's using multi-factor authentication or not. So here's an example, for example, where we have a suspicious user login from multiple locations. This is just an example of how you can start visualizing login issues and authentication issues. So let's talk about some of the skills. In a survey, we basically asked people, what are the key security visualization skills that are out there? People focused on that term security analytics a lot. Anybody here a security analyst? Okay, you made a big mistake in raising your hand. How long have you been a security analyst? How many years? Shout it really loud. I can't hear you. 10 years. Day in and day out, what are a couple of the activities that you do? And shout them out very loud so everybody can hear. Say that again. You architect things? Yeah? Okay. So you basically put together the solutions to make sure that they're properly done. Right. So risk analysis, these are the skills that can help. And interestingly enough, project management came in. Does that ring a bell to you, like project management, why that would be important or not? Yeah. It's about process, you're saying, right? Very important. So the whole idea is with network planning, but visualization and writing skills came up in there. So let's talk about some of the specific things that you can do. First of all, implement a SIM. Second of all, and this is an example of a SIM, this happens to be RSA Security Analytics. There are many of them out there, right? The idea is that this can help you visualize things. But how many of you have access to $20,000 to go out and buy a SIM? Oh, really? What a surprise. So how about a poor person's SIM? Anybody ever heard of an application called Ether8 before? Or Wireshark? You guys know Wireshark, don't you? See this right here? That is an example of a Tor network, and it's an improper one, right? We don't know why it's there, right there. This here is also an example of a Tor network, right? Now, if you had to go to your boss and explain, hey, there's this network, we don't know what it is, which is more instructive? And don't say neither. Which is more instructive? That? Or, look, we've got ourselves traffic here that we don't understand, and it's significant volume here. It's the idea of visualizing. When it comes to endpoints being attacked, and I have to confess, this works on various endpoints. Doesn't work on IoT devices, sorry, but this will work on almost any other IoT device, on almost any other type of device. This here is tracking TCP-based ICMP-based connections to a system. This can also monitor, it's called a Performance Copilot, PCP. It can monitor existing, your local system, or it can monitor remote systems. It can also monitor things like processor use, how many threads have been launched, and it gives nice visualization, right? This here is an example of an application or a service called BRO. It's not a Security Information Event Manager. BRO, back there I see some smile, right? It's very nice for network heuristics. The point being, instead of focusing on, oh, hey, there's something bad. My signature database tells me there's something bad. What it does is it basically starts pointing out, we're noticing trends, right? And this is an ugly log file here. But look at all these DNS unmatched replies. What does that mean? First of all, it means that somebody is going out. There's some system on the network that's going out to the network using another DNS server that is not authorized. What's going on there, right? And it's not saying that's a signature that it's met. It's actually just saying, we're noticing this anomalous traffic. Now, that's really an ugly file, but what you can do is you can visualize it here. And look at that. You can see over time that you have a spike in that kind of DNS activity, and now you can show your boss, we seem to be finding that there are some major anomalies here. And by the way, Performance Copilot and BRO, guess how much they cost to use? Your time to install it. They're open source. Okay, moving on. Wanted to show what it means to visualize issues. This has to do with a company that has a lot of Oracle devices installed, a lot of Oracle services. And what they did is they noticed that their authentication their authentication systems were starting to run into some problems. And so what they did is they started at visualizing logins over time, and they noticed that there were repetitive logins happening that were frankly not authorized. So they were able to basically drill down by service right into a specific problem and then take action to set up priorities to solve certain problems there. I'll skip along here. Now, we've got about a little bit less than 10 minutes left on the presentation. Today, we talked about major changes in security, right? The ways that the attack surface increased. We talked about the importance of visualization and talking to your boss. We talked about the technological changes and about why it's so important to have proper visualization and some of the essential issues and some of the kind of skills and tricks that you want to get going. If you want to learn more about this sort of thing, I don't know if any of you are attending the mini boot camp tomorrow that we are putting on for our CSA Plus. We got you, right? We'll be doing some demonstrations of some of these tools, right? But I want to, let's see, we've got about 5 minutes, 10 minutes left. I'm curious if anybody has any questions. If you don't, I'll continue. I could continue on and talk about a couple other things. Does anybody have any questions about some of the tools that I discussed? For example, EtherApe or Wireshark, any of those types of things? My alarm just went off. Now I've got to find a way to turn it off. There we go. There we go. One of the things that I noticed when it came to visualization, so you go back here. There we go, going back to here, is the importance of using various tools. How many of you use Wireshark on a daily basis? Okay. How many of you use Bro or Snort as well? Okay, a few of you, right? Now, you have to be using something other than Wireshark. What are some of the tools that you use? Anybody care to shout out some of the tools that you use besides Bro or Snort? Nothing? All right. Other things, one of the SIMs that is really big out there that's an open source one, it's called Alienvault. And that's a highly, it's used a lot. They have a for-fee one that you have to pay for. They also have an open source one. Very effective. And also there's Nessus, the vulnerability scanner. Nessus users out there? How many of you OpenVAS using that, right? Anybody prefer, what's some of the issues with OpenVAS versus Nessus? I'm curious why you would choose OpenVAS, for example. Do you find it easier to use or what have you? Maybe you can stand up and...
We found it Is this on? Can you hear me? All right.
It is, yeah. These microphones
found
are
that exporting reports from the Greenbone Security Manager was substantially easier than it was from Nessus, and it allowed us to be able to export into XML and parse it into our own proprietary web-based dashboards.
So the dashboards, so you had application developers create your own dashboards out of that info?
Yeah, we basically created an executive-level dashboard for lack of a better way of doing it. Your lay decision makers that need keep it simple stupid so they can identify where they need to better allocate resources but don't have the technical savvy. It allows us to parse it down much easier because of the way that you can effectively export easily from OpenBOS versus
Give me an
Nessus.
example of when you had to allocate resources. You know, what did it come to here's where we do end user training, or did it come down to, okay, here's where we have to place some sensors?
Well, what it came down to was that they were noticing that the vulnerabilities, the critical vulnerabilities, weren't trending down over time, although his people were saying, we've taken care of that.
But
he had daily visibility into the fact that they were whitewashing the results. They couldn't do it anymore, so he basically came back to the team lead and said, you're telling me this is done, the vulnerabilities are still coming up. It has not been remediated. It has not been the risk has not been ameliorated. So what do I need to do to help you fix this? It wasn't about assigning blame. It was about making sure that the C-suite folks, the ones that could lead from the top down, had proper visibility.
Well, I'm curious, were these systems that said, okay, we took care of it, and then they actually hadn't, was it in fact that, or was it that systems kept getting reinfected because the patch level wasn't right, or there was a zero-day attack, or was there any of that ever?
What we noticed in a lot of cases, especially in manufacturing and logistics, is what we deal with a lot because we're headquartered up in Allentown, Pennsylvania, which is a large distribution hub.
Sure. Yeah.
Is that IT is at most a bastard stepchild, and in best case, an undesired afterthought. In a lot of cases, the people that are on staff are putting out fires that are impacting productivity or timeliness to getting logistics out the door. So they end up putting out fires, and then they go, okay, yeah, I'll get it done, I got it done. At the end of the day, they go, oh, crud, I'll take care of that first thing tomorrow morning. 6 months later, 2 years later, and in one extreme case, 6 years later, nothing had been patched.
6 years later.
Yeah.
You know, one of my favorite stories is basically where our email administrator had a problem because each time we came into work, right, every morning we came into work, it took about 20 minutes for our email to show up, right? 20 minutes. I mean, when you check your email, how long do you want to wait for your email to show up? Trust me, it ain't 20 minutes, right? And then one day, you were talking about how certain things take priorities, right? Because I've always found access to services always trumps securing services, right? So what happened was one day, suddenly our email was showing up instantaneously. It was like, oh, holy cow. Well, what happened? The email administrator was also the security administrator, right? She was responsible for both. So she basically noticed that the firewall was really the bandwidth problem. The firewall was the choke point, right? Was the what am I looking for? It was basically where there was a problem with bandwidth, right? So it wasn't the email service. So what she did is she basically banged another NIC into the she banged another NIC into the server, right, in the email server, and attached it directly. Right, as it were, to a switch that was directly attached to a router that was attached to the CSU DSU, completely bypassing the firewall. So email was instantaneous now, right? So the CEO called us in and said, "Hey, I think you need to go and find out, why this is so good now. What happened, right?" In other words, she basically solved a problem of service, right, and bypassed security. It's a classic issue of not segregating duties. But I find it interesting that, I think that's absolutely a major thing that visualization can do, is to help focus on major issues rather than security issues rather than just access. So thank you very much. And yes, you may sit down now. So, yeah. All right. It's 10 after. Any other questions or comments? Let's see. Who was it who said we have to spend an hour here? Right? I think we're fine. Right. One thing I would like to point out again, having to do with this particular setting up Bro. I'm curious, over here you said you used Bro. Who was that? How long did it take you? I think I might make you stand up here just for a second. Who was that? Yeah, you're in trouble now. I'm curious how long it took you to set Bro up to where, huh? Say it again, Tom.
It takes a long time.
Yeah, because I found that, first of all, this particular configuration file, oh, no, you're not out of it yet. When you say a long time, how many days? How long? You know, you're not out of the... Weeks. And so, was that because you had to basically set up what were kind of safe networks and not safe networks and networks that you were listening to and everything? And what tools did you use to help test whether that Bro implementation was working or not?
Security Onion.
Say it again?
Security Onion is a solution.
Security Onion, using that. Okay, very good. So what I find, folks, is that the key is not so much in compliance, right? And the key isn't so much just showing pretty pictures. It's basically taking the time to customize your implementation for your network so that you can end up not with too much information like this, but with information that can show you those types of trends. So without any further ado, what I'll do is I'll put up a screen here. If you want to grab a copy of this slide deck, you can put it. Let me see if I can set this up properly. You can... I'll just forward to it again. You can go to my Twitter feed, right, and grab a copy of it. If you have any questions or comments, you can also contact me via Twitter. I'm happy to answer any questions afterwards. But this will basically conclude the presentation. Thank you very much for your time at coming to AFCEA. And for those of you who've signed up for the boot camp, where Stephen Schneider will be there, Patrick Lane, and folks and others will be very happy to answer any questions there. This here is just an example of some of the articles that I've written. There's one here about configuring Bro, if you're interested in that. And if you want to get a hold of me, happy to get a hold of me. Happy to answer any questions that you have. So everybody, thank you very much for your time. Appreciate it. And you can get scanned afterwards. So there you go. Take care.